So let's talk about how to write the equations of exponential functions. It's very, very simple. It's a lot like writing the equations for linear functions or any of the other kinds. So we're going to first review linear and how to recognize linear functions so that we can know the difference between a linear and an exponential. If you will remember, to check to see if something is linear, the first thing I have to do is check the differences in my table. My x values here all increase by 1. Negative 2 to 1 is 1. Negative 1 to 0 is 1. They all increase by 1. So I'm going to check what the differences is for my y values. So from negative 4 to negative 1 is an increase of 3. And from negative 1 to 2 is another increase of 3. 2 to 5 is still an increase in 3, and 5 to 8 is still an increase in 3. And so I have a constant rate of change. It's all increasing by 3. So to identify a linear function, whenever the x values increase by 1, the y values increase or decrease by a constant rate. And in this case, that constant rate is 3, and so this becomes our slope, or our m. So the slope of this function is 3 over 1, or 3. So m is 3 for this function. So then you go to look at the rest of it, because you've got to know what b is, because we've got to remember the y equals mx plus b, this fancy equation from way back when, for a linear function. The slope is going to be 3. There's my rate of change. B is where x equals 0. So the point where x equals 0, y equals 2. That is our y-intercept, which is what we call b in that equation. So b is 2. Therefore, my equation for this table is going to be 3x plus 2. Just a review of linear functions so that we can remember how to do those so that you can see how they are different from the next set of equations. So let's talk about how to identify exponential functions. I'm going to start here looking at the x values. They all increase by 1 again. That's really important. If the x values don't increase by 1, things change. So if the x values increase by 1, I want to check the y values. I'm going to do the whole numbers first. I don't want to do an increase. What I want to look at is what is the constant factor? What's the constant scale factor? So from 2 to 6, I had to do times 3. And from 6 to 18, I had to do times 3. And if you look at it here, 2/3 times 3 is going to give me 2. And if I look at this also, 2/9 times 3, that should be a times, not a plus, becomes 6/9, which reduces to 2/3. And so my constant factor is going to be times 3 instead of plus 3. So I'm not adding 3 every time, I'm multiplying 3 by 3. So the y values have a constant factor. So it's being multiplied instead of added or subtracted. So this is your b value. So our b value for this exponential function is going to be 3 because that's my constant factor. Now when x equals 0, y equals 2, I got that from the table. That's going to be my a value. If you remember, exponentials are y equals a times b to the x. And so my a value is right here. It's going to be 2. And so my equation for this is going to be 2 times 3 to the x power. I got the 3 from my constant factor, and the 2 is my y-intercept. And that's how I wrote the equation. So the difference between a linear function and an exponential function. Linear functions have a constant rate, so they are adding or subtracting the same number every single time. Exponential functions have a constant factor, so you should be multiplying by the same thing every time. Let's do a couple of examples. So let's check first to decide what kind of a function this is. X values all increase by 1, so let's check differences first here. Oh, wow. 128 to 32, well, that's a difference of negative 96. And then from 32 to 8, that's a difference of negative 24. Well, I already do not have a constant factor, so I know it is not going to be linear. I can check to see if it's going to be quadratic, but we're only comparing linear and exponential today. We're not going to have any quadratics going on, so I know it's not linear because doesn't have a constant rate of change. So I'm going to have to see what the constant factor is. I'm going to start with the smaller numbers first and I'm going to change colors because it will help y'all to see that I'm writing something different. I'm going to start with these numbers first because it's easier to see. To get from 8 to 2, what is my constant factor going to be? Well, it's 8 divided by 4 is going to be 2. So it's going to be divided by 4, but I want a constant factor, so I want to be multiplying. What is this? What can I multiply by that would be the same thing as dividing by 4? Well, I could multiply by 1/4. It's the same thing. So 8 times 1/4 is 2. 2 times 1/4 becomes 2 over 4, which is 1/2. And if you look at these here, right here from 32 to 8, well, 32 times 1/4, or 32 divided by 4, is 8. And I'm willing to bet that if I do 128 divided by 4, it equals 32. So my constant factor here is going to be 1/4. So the type of function I have is exponential. And I know it is exponential because it has a constant factor and not a constant rate of change. So this is exponential, so my equation of my function, it's got to be in this form, a times b to the x. The 1/4 is my b, and this value right here, my y-intercept, is my a. So a is 2, b is 1/4, and I'm going to put that in parentheses because I want the whole thing to be to the power of x. So it's 2 times 1/4 to the power of x. And if we go back and remember what we talked about in class today, what this should also tell you is that since this is 1/4, that it is going to increase at a slower rate than if it were just 4 to the x instead of 1/4 to the x. It's going to slow down the rate at which it increases. This has a slower rate of increase than other functions. But this is exponential because it had a constant factor. So let's test this one. X's are all going by 1, so let's first see if it's got a constant rate of change. From 1 to -1 is -2. From -1 to -3 is also -2, -2, and -2. So you should see you have a constant rate of change. That makes this bad boy right here linear because it has a constant rate of change. So my slope for this function is -2. So I got to start with -2x. This right here is my y-intercept, so it becomes -2x minus 3. There's my function. So you see the difference between linear and exponential. Let's do one more. This is written as a list of numbers. So the first thing I'm going to want to do is turn this into a table. My x values are -2, -1, 0, 1, and 2. And then my y values are going to be 3, 9, 27, 81, 243. So they're getting really big really fast. That should be a clue to you right there that that is probably going to be an exponential function. Let's test to see if it's linear first. From 3 to 9 is +6. From 9 to 27 is not +6, so not a constant rate of change. It means it's going to have to be exponential. Let's find our factor. This becomes times 3. This is times 3. Times 3, and I'm willing to bet that's also times 3. That makes this an exponential function because it has a constant factor. So my b is 3, my a is 27, so it's 27 times 3 to the x. That's my function. And that's how you go about doing that. So let's look at one more. Okay, I have the data that represents the relationship between the amount of bacteria over time. So I have how long I've been looking at it and how much bacteria is there. And we talked about bacteria the other day and how they multiply and that they just double and double and that it's exponential. So you should already know. We're talking about bacteria. It's probably going to be exponential. But we're going to plot the points and then connect them. So I have 0 and 10, 1 and 20, 2 and 40, and then 3 and 80. And if you connect these, I know y'all are going to say that it probably looks like a quadratic, but if you will look at it, okay, it appears to represent quadratic because it looks like a parabola, but it's not. It's going to be exponential. And here is how I know, okay? It starts slow. So you see it is increasing slowly right here. It went from 10 to 20, and then 20 to 40, and all of a sudden it jumped 40 to 80. And so then it ends quickly. So it ends fast. So the rate of change, it increases very quickly. So the rate of change is increasing very quickly, and it does not have a constant rate of change. Where it says what type of exponential function does it represent, they're asking is it increasing or decreasing? Well, look at your pretty little picture. This one is increasing. So it is an increasing exponential function because the numbers are going up. We're going to write an equation to represent this data. First thing I got to figure out is my change. 10 to 20 is times 2. 20 to 40 is times 2. And 40 to 80 is times 2. So my constant factor is going to be times 2. And then this is my y-intercept. So I've got to start with my 10 times 2 to the x power. There is my function. So now the question is to predict how much bacteria there would be after half a day. Well, if x is my number of days, that means I want to find out what 10 times 2 to the 1/2 power is. Okay, so all you have to do is plug that into your calculator and get that as an answer. So you have 10 times 2 to the 1/2 power, which is going to be about 14. Now use your calculator and use the table function to answer the last question. You will share that information with me when you get here tomorrow. Please remember that if you do not have notes when you get to class, you will not get to participate in the M&M activity and you will miss out on the yummy, yummy M&Ms. I will see y'all tomorrow. Have a good day.